Another tool for simplifying trig expressions is eliminating fractions. And we're going to do this by multiplying by the conjugate. Now remember, a conjugate basically means that you just switch your middle sign. We've simplified square roots with the conjugate before as follows. Here we'll multiply root 2 plus 1 by root 2 minus 1, just switching that opposite sign here. If we distribute everything out, we're going to end up getting 2 minus root 2 plus root 2 minus 1. Check out how these two middle terms, negative root 2 plus root 2, are going to cancel each other out, leaving us with just 2 minus 1, or 1. So by multiplying root 2 plus 1 by the conjugate, we could get all the way to 1. Let's try simplifying 1 over 1 plus cosine x by using this method. Let's go ahead and multiply by the conjugate. That's going to be 1 minus cosine x. And of course, what you do to the bottom, you got to do to the top. And that's going to give us, if we distribute this out, 1 times 1 minus cosine x. That's just 1 minus cosine x. All over, and if you distribute all of this out, you're going to end up with 1 minus cosine squared x. From here, we could take our 1 minus cosine squared x, use our Pythagorean identity, seeing that if I subtract cosine squared x from both sides, I'll get sine squared x equals 1 minus cosine squared x, and I'll replace that here. That leaves me with 1 minus cosine x over sine squared x. Alright, let's pause for a second and look what we've got here. 1 minus cosine x over sine squared x. Well, we can't use our Pythagoreans anywhere. We've condensed this pretty much as we can do. So we find ourselves kind of at a crossroads. Now when you have in some scenarios, it is beneficial to separate your fractions out, right? Instead of getting common denominators and combining them, let's see if we can separate this out. So rewriting this, that would give me 1 over sine squared x minus cosine x over sine squared x, right? These have common denominators. I could combine them back to get right back where we started, 1 minus cosine x. I've just rewritten them as two separate fractions. From here, I see I have 1 over sine squared x. Well, I could use my reciprocal identities, seeing that 1 over sine squared x has to equal cosecant squared x. These reciprocals always work even if you have a squared term. So this 1 over sine x is going to turn into cosecant squared x. Notice this is more simplified than this because it's not written as a fraction. Let's take a look at our second term here. Here we have minus cosine x over sine squared x. What if we rewrote this as cosine x over sine x times 1 over sine x? All I did was split this sine squared x into two separate signs. Now I have cosine x over sine x. That is one of my quotient identities, which is cotangent x. And I could rewrite that here. Instead of minus cosine x over sine x, I'm going to write minus cotangent x. Then I have 1 over sine x. Again, that looks like my cosecant x, and I could write that there, cosecant x. Now that my fractions have been eliminated, I have completed my goal, and we'll say that this is simplified.